Hey, what's going on, guys? In this video we are going to see an example of mixing problems. Here this question is asking a tank contains 1000 liter of brine with 15 kg of dissolved salt. Pure water enters the tank at a rate of 10 liter per minute. The solution is kept thoroughly mixed and drains from the tank at the same rate. How much salt is in the tank after t minutes? Okay, so first of all we have to know what's the equation we are going to use. So when we are dealing with this kind of mixing problems, the generic equation we usually use is this one. dA by dt is equal to concentration in multiplied by rate of water flow minus concentration out multiplied by rate of water exit rate of, in this case that is salt, but let's write as water exited. Okay, now concentration in, here they have mentioned pure water is entering the tank. So pure water means the concentration is 0 and entering rate is 10 liter per minute multiplied by 10 liter per minute, and then minus concentration out. Here we have 10 liter entering and then concentration out. Here we have to introduce one more term, that A of t, that will be the amount of salt after t minutes in the tank. So let's say A of t, this is going to be the amount of salt after t minutes in the tank. Okay, so this is amount of water, and if we divide amount of water by this liter, that's going to be the concentration out, 1000 liter. Okay, now the rate of water exiting is also same, that's 10 liter per minute. Okay, 10 liter per minute. Now here from this one we can see that this is 0 minus A of t divided by 1000, liter cancels and we will be left with minute. So let's forget about the unit for now. So multiply by 100, so I have 10, so one of the 0 cancels, so we can write it as minus A of t over 100. Okay, now we can simply write this one as dA by dt is equal to negative A of t divided by 100. Now from this one you can see this is a separable differential equation, so we can move this A to one side and t to the other side. So this is going to be 1 over A dA and negative 1 over 100 dt. Okay, let's go ahead and continue right here. Now we have to integrate both sides. Integrate this one. If you integrate this one, this is going to be just ln of A, and if you integrate other side, you're going to get, that's going to be ln of 1 over 100. Okay, this is just a constant, so we will get negative 1 over 100 t, and also we have to add a constant. Now to find out the constant, we have to look at the initial condition. So initially we are starting with 15 kilogram, so the amount of water initially, amount of salt dissolved is 15 kilogram initially. So A of 0, at time 0 we have 15. Okay, so A of 0 is 15. From this one we know that this is our t value and this is our A value. Now we have to substitute these two values to find out this C. So this is going to be ln of 15 is equal to negative 1 over 100 times 0, that is equal to plus C. This one is going to become 0, so C is equal to ln of 15. So we can express our particular solution right now. Let's use a different color. So here we just have to replace this C with ln of 15. So ln of A is going to be equivalent to negative 1 over 100 t plus ln of 15. Okay, now to get rid of this ln, we can e power all of them. If we e power, e and ln cancels each other, we will end up with A is equal to e power negative 1 over 100 t times 15. Okay, Finally, we can express this one as a is equal to 15 e power negative 1 over 100 t. Okay, this is a particular solution for this differential equation. I hope this helps. Thanks for watching, and don't forget to subscribe. And if you are trying to learn differential equation, there are a bunch of videos in my playlist. I hope you guys watch that too. See you next time.